Milk is defined legally as the natural mammary secretion obtained from healthy dairy animals, usually cows, and it must be produced under hygienic conditions. According to Mexican regulation No. 55 and similar definitions in Singapore's Sale of Food Act, milk must not contain any added or removed components. This means it must be pure natural product in order to be safe and nutritious. To ensure milk quality, several physicochemical parameters are monitored. These include fat content, which should be around 3 to 3.5%, protein contain around 3%, solids not fat about 8.3%, density close to 1.029 grams per milliliter, and acidity between 0.13 and 0.70%. In addition, microbiological safety is essential. Milk should be free from pathogenic microorganisms such as E. coli, Salmonella, and Listeria. When a milk sample does not meet these standards, adulteration is suspect. Food adulteration is defined as any intentional act to modify a product by adding, removing, or replacing components with the purpose of devising the consume or reducing product costs. Both Mexican and Singaporean legislations classified adulterations as illegally and a threat to public health. In the case of milk, adulteration is unfortunately common in many countries. Some of the most frequent adulteration include water, which dilutes the milk and decreases its nutritional value; sugars, starch, or salt, which are added to disguise the dilution by maintaining density; and chemical substances such as hydrogen peroxide or formaldehyde, which are illegally added to slow spoilage and make old milk appear fresh. Neutralizing agents like sodium carbonate are also used to hide acidity caused by bacterial contamination. One of the most serious cases worldwide was the contamination with melamine in China in 2008, which was added to fake higher protein content and resulted in severe kidney damage in thousands of infants.
Following the introduction about milk and its characteristics, we can begin with the density test. That is a simple but key analysis to evaluate its composition and quality. Density reflects the proportion of water, fat, and solids in milk, and small variations can indicate dilution or fat removal. According to the Norma Oficial Mexicana, full milk must have a minimum density of 1.029 grams per milliliter, which ensures that the product has not been altered or adulterated.
Cryoscopy is a direct authenticity test. Real milk is near to minus 0.53 to minus 0.55 Celsius degrees, and if the value is less negative, it suggests dilution and is necessary to homogenize the sample, control nucleation, and record a stable temperature with a calibrated cryoscope, and also is necessary to repeat readings and verify daily with a reference milk so results are defensive. Titratable acidity tells us how acidic the milk really is, and by measuring how much sodium hydroxide it takes to neutralize it. Fresh milk is usually tea. Measure fat percent and total solid percent. Compute S and F percent, that is equal to total solids fat. We check fat and S and F against the specification, and for dilution screening, we combine S and F with the freezing point. If we combine S and F with freezing point closer to 0, it strongly indicates adult water.
Now the method we choose is titratable acidity, that represents the total amount of acids present in milk, mainly lactic acid, which forms naturally as bacteria break down lactose. Unlike pH, which measures how acidity something feels at the moment, titratable acidity measures how much base is needed to neutralize all those acids. giving a more complete idea of the milk freshness and stability. And when acidity increases, it actually means that it's fermentation or spoilage, but if it's too low, it might indicate dilution or adulteration, and that's why this parameter is so important because it connects chemical balance with product quality and safety, allowing us to detect changes before they are visible or harmful. For the comparison of regulation, we analyzed the standards from Mexico and Singapore. In Mexico, we searched for two norms, and they established that they have strict quantitative limits for fat, density, acidity, and microbiological safety. In contrast, Singapore followed the Singapore Food Agency and the Codex Alimentarius, focusing mainly on general safety and accurate labeling. Although both aim to protect consumers, in Mexico cases of milk adulteration are more frequent, which explains why national standards are stricter and more detailed. Meanwhile, in Singapore faces fewer incidents, allowing for broader regulations centered on prevention and consumer confidence. So now what's the importance of analytical chemistry? It plays a crucial role in understanding and controlling the quality of milk. It provides the scientific tools to detect adulteration, quantify key components, and ensure compliance with official standards like the NOM 135, SCFA 2012 by applying precise methods such as density or acidity determination, and it becomes possible to identify even minimal variations that can affect safety and nutritional value. And beyond the laboratory data, analytical chemistry connects science with ethics and public health, helping protect consumers and maintain confidence in the food industry.
In conclusion, milk is a highly regulated food because of its nutritional importance and health risk associated with contamination or adulteration. Preventing milk adulteration is not only a legal and scientist responsibility, but also an ethical commitment to society. Strengthening regulations, improving laboratory analysis, and promoting honest industry practices are essential steps. At the same time, artificial intelligence represents a powerful ally that can transform the way food safety is monitored, helping protect consumers and rebuild trust in the dairy industry. Thank you for your attention.